Welcome to Maintainable, the podcast where we explore the art, and sometimes the mess, of software that lasts. I'm your host, Robbie Russell. Today I'm joined by Russ Olsen. Russ is an independent software consultant and author who's been in the industry for over, 4 decades now. He's managed teams from, 3 to 120 people, worked in organizations with 5 developers and 5,000, and he wrote his first program using punch cards on a mainframe. Russ joins us from the Washington, D.C. in the United States area. Russ Olsen, welcome to Maintainable.
Hey, it's great to be here. Thanks for having me.
So given your experience in the industry, what do you believe are a few common characteristics of, dare I say, well-maintained software?
That is a great question. And like all great questions, the answer is it depends. It depends on who's doing the maintaining, what's the goal of maintaining the software, right? We tend to talk about maintainable as if this is some standard that we all understand, and I don't think that that's true. How long are they going to maintain it? And what kind of software are we talking about? And, I've been in the industry a really long time, so maybe I have a different perspective, but, I've worked on a team that built a database and they had one set of ideas of what maintainability was. I've worked on device drivers. That's a completely different set of what is a maintainable device driver. And I worked on a system that kept track of where the locations of landmines so that civilians wouldn't accidentally step on them, like landmines left over from wars.
Literal landmines.
Literal landmines. That's a different standard for maintainability. I think the one thing that makes software maintainable is that it has to be understandable to the people who are maintaining it. That's kind of obvious, but there are all kinds of dimensions of what does it mean for software to be maintained, to be understandable. And mostly, we think about documentation. So you will hear people say you should document your software, right? Obviously, you should document your software. But we are really good at documenting finer points of the software. This function does that. This class is for, this purpose, that kind of thing. We're less good at documenting the bigger issues. The subsystem does this. That tends to get lost, at least more than the individual functions or something like that. But even more than that, I worked for a bank for a while, and we were always trying to maintain the documentation that went like this. A customer uses a credit card. 77 microservices later, the merchant gets paid. And 77, I'm making these numbers up, microservices later, the customer gets billed, right? That is the kind of documentation that is really hard to find. And then there's even another dimension of documentation that makes for maintainable software, and that is the solution space documentation, where why did we do it this way, right? Because everyone who's ever worked on a big system, I suspect, everyone who's worked on a really large-scale software system that's been around a while has this experience. You look at something and you say, what were these idiots thinking? Why would anyone do it this way, right? I can sort of see you're nodding. And then so you do it some different way, or you start to do it some different way, and then it becomes all too clear why these idiots did it that way. And there's a friend of mine, a guy named Mike Nygaard, colleague, is a big advocate of these things called architectural decision records, which have been so much a part of my career for a long time that I'm not sure who knows about them. But what you do is when you come to a big decision in your software, we're going to, add a relational database or something like that. You sit down and you write a document that says, here's the context of this decision. Here's the problem we're trying to solve. Here's the solution. We're going to adopt the relational database to do something. And then the critical bit is, here are the trade-offs. Here's why we didn't do it a different way. And I think in that of, this is what these idiots were thinking when they made this decision. And it's for the future people not to, painfully retrace those trade-offs. And I will pause and take a breath here.
It's interesting because I work in client services, so I'm almost even thinking about just the example of when a client will approach us with like maybe an RFP or something, and they might go out and talk to 5, 10 different potential technical vendors to work on that project, and we'll submit our proposal for something, and maybe we're the ones that win. I don't know that like in several years, like it's very obvious, like what were the other options that the company was deciding. But it's like, I think that's like, it's almost like that level, but then you get down into the level of what decisions did we make to put our proposal for, it's like the path that won, I'm air quoting won or was decided upon or agreed to move forward with, given the budget and the time and resources to make it happen, it kind of like everything else starts to kind of go away. And I don't know that everybody thinks to capture that information and to put it somewhere and that people will think that they'll go back. It's also an interesting thing of like, because that's not often documented, do people even, if you did document it for whatever reason, would anyone even know to go look for it?
Yeah, I mean, I think that is, so if you are a lone developer off in the corner somewhere, and no matter what documentation you're writing, it's probably not going to help. It needs to be kind of a part of the process of whatever team you're on. Yeah, I think you make a great point there, which is that, the decisions that we make with software, really in life in general, right? Like life is amazingly complicated. And so I think the way our minds work, particularly when we're dealing with like really hard problems, kind of things you find in software, the way our minds work is we try and narrow down the problem space and the solution space so we can find the solution. So you sort of said it. We made a decision and we kind of forget about everything else. And that is exactly the moment, like 5 minutes before you've forgotten about it, write it down because it will be valuable. The people who come along after you, or maybe you in 2 years or something, you're going to be so enmeshed in the decisions that have already been made that it's going to be hard to see what, why they were made, to see the unsimplified version of the world. And so by writing it down, you can sort of say, we took this decision because of cost. Maybe there was no technical reason to make it other than it was going to, the alternatives were too costly. But now you're working in a company that is flush with money. You can do something else. Or we did this because after long thought, this other alternative was a disaster. You did all that long thought. Maybe you should save the result of that long thought. Lawyers have what's the term lawyers use? I think they call it work product, which is, I did the work on this brief and that is my output. And that's the valuable thing that I'm producing. Don't throw that away.
That makes a lot of sense. I think that's some good advice, and kind of curious for anyone listening out there, where do you document these types of things and where do you capture that and know to go back and reference that? So Russ, one of the reasons I wanted to have you on the podcast was that I want to touch about your writing. And I have recently got a copy of Eloquent Ruby 2nd edition, thanks to your publisher, and it's on my list to dig into in the next few months. And so I haven't had a chance to do a deep dive yet, but it's been recommended to me more times than I can count by peers, especially your 1st edition. Like, who out there should pick up a copy of this book? Who do you tend to think would get the most value from it?
So I'm probably the last person you want to ask that question, because my answer is, everyone who can read, right, should buy a copy of my book. That's always and a few of those other people too. But in all seriousness, I think if you are a Ruby programmer, if you are relatively new to the language or struggling a little bit, or even someone who's been in and out of the Ruby world for a long time, but you're sort of coming back to it. Because the goal of the book is not to teach you how to program in Ruby. There's 100 resources for that can do a better job of it. The goal of the book is to teach how Ruby is actually used in the world. And also and this goes back to the thing we were just talking about, also the thinking behind why it's done the way it is done, right? Not all of the sort of common design choices in Ruby are great choices, but they all have some history and some reason behind them. And you are better off, if you're a Ruby programmer, understanding why things are done the way they do. I will say this, I'm probably not the person to ask, but I have had people who've read the first edition who's never written a line of Ruby code say that it's just refreshing to sort of read a book which is sort of talking about the balances between, well, you could do it this way, but that's probably a bad idea because of this, that kind of thing.
Interesting. Can you give me a couple of examples of things that the book tends to dive in for our listeners? Is it here's different ways to think about OO, or is it more of like here's different ways to approach using classes versus module?
Yes. So Ruby's a dynamically typed language for the most part. There have been attempts to sort of put a statically typed facade on Ruby, but the vast bulk of Ruby code is dynamically typed. And I think that if you're sort of coming from the statically typed mindset, it takes a long time to really get used to the idea that this is a feature and not a bug, right? So there's a lot of aspects of Ruby where, the Ruby sort of philosophy, which is built into the language and also built into the heads of Ruby programmers, is if the method I'm trying to call is there, then this is the right kind of object. Right. That is then, it's the duck typing thing. That can be remarkably subtle. I actually had some experience with Groovy, which is a sort of Java Ruby knockoff, if you will. It's sort of obviously modeled, but it has optional typing, right? So you can put the types in or not. And the number of times you will see, at least in the Groovy project that I worked on, where people will declare types that reduce the functionality of some piece of code because they're looking at it and they're saying, this is obviously an int and that is obviously an array, when in fact, this is some numeric value and that is some collection. And it sort of narrows down the utility. I also think there are a bunch of simply, and this is true, I think, of all language, programming language communities, there are a bunch of sort of stylistic things that people who were maybe not so entrenched in the language will tend to ignore or tend to think aren't very, very important when in fact they are really important, and you can always tell someone from the Java world coming into Ruby because they will write a bunch of methods where there are generators for the methods where you can do a one line and it generates, the getters and setters, if you will, that kind of thing. But really it's a little bit like, your question is a little bit like saying for someone coming to English who's a native speaker of some other language, what do they need to know the right English that other people can read? And it's like, that's kind of an impossible question.
Hey listeners, it's Robbie here. It wasn't all that long ago I'd find myself debugging a weird issue in one of our clients' Rails app. I log into one platform to track down the error, only to realize it was tied to some performance issue. And guess what? That meant hopping over into a completely different tool and trying to match things up based off of timestamps, if I was lucky. And let me tell you, my productivity didn't exactly thank me for that. Enter AppSignal, our podcast sponsor, and the tool that eliminates all that back and forth. They bring error tracking, performance monitoring, host metrics, custom metrics, uptime monitoring, and logging into one seamless platform. It's a single source of truth that helps keep your app running like a well-rehearsed symphony. Whether you're working with Ruby, Elixir, Node, Python, or tracking front-end errors in JavaScript, AppSignal has your back. They're always adding support for more languages and frameworks too. And here's the best part. AppSignal won't break the bank. Plans start at just $23 US a month. Plus, they're ISO 27001 certified and fully GDPR and HIPAA compliant, so your data is safe. Oh, and because you're a loyal Maintainable listener, you can use the promo code Maintainable at checkout for 10% off your first year. So head over to appsignal.com, tell them that your good friend Robbie from Maintainable sent you, and start making your app sing. I can appreciate that. Do you think of Eloquent as, it's an interesting word to use there. And I think in the Ruby community, because as a fellow Rubyist, we hear words like Ruby is beautiful on its own, right? And so it feels slightly subjective in a way, like a way to like kind of like how
it's utterly subjective.
I mean, so it's like, is this Russ Olsen's personal taste here, or what does eloquent even mean to you, Russ?
When I started out, seems like half a lifetime ago now, when I wrote the first edition, I simply wanted to write a book that explained all the Ruby things that we all know and therefore no one ever talks about, right? You sort of talk about cultures and teams and things like that. And it's always culture is the stuff you don't talk about. Just everyone knows. Except that if you're a newcomer, not everyone knows. As I say, I wanted to write a book that talked about the things that everyone knows. And some of those things, like I like Ruby and I like mostly the way Ruby's written, but I don't, I can, take some piece of like pretty standard Ruby code. I won't necessarily agree with all of the stylistic choices or that kind of thing. That was not the goal of the book, was not what does Russ Olsen think. The goal of the book was how is it actually done? I'm not talking about my opinions. I'm talking about how it actually, what the, average Ruby person thinks. What, if you dug into some popular Ruby open source program, how would it be done, right? So Ruby's pretty easy, right? Digging the Rails is always everyone's first go-to. Not everything in there do I agree with, but that wasn't the purpose of the book. Well, the book does sort of, you can tell when I don't agree, but I will tell you what it,
I can appreciate that. Thinking about connecting this back to, say, maintainability. So where do you think eloquence helps support maintainability? And where do you think it maybe becomes a little bit of a liability?
I think in general, in Ruby, people have this idea that if I can write less code, it's probably better. That's not unique to the Ruby world. But I think if it's from 1 to 10, if it's a 6 in general programming, it's probably an 8 or a 9 in the Ruby world. And I think that's good. I think by and large, maintaining some software is a function, the difficulty of maintaining some software is a function of how much software am I maintaining. Except you will occasionally see Ruby people go all out and create something amazingly complicated to save a handful of lines of code. They've kind of lost the thread of maintainability. And I'll say something that may be a bit controversial. I wish RSpec would just settle down, right? RSpec, it's the Ruby testing tool, and it not only changed amazingly between the first edition and the second edition of Eloquent Ruby, you would expect that years have gone by. It changed while I was doing the second edition in fairly significant ways. And that is not, and I'm sure every single one of those changes made sense in the smaller scale. In the larger scale, the thing you want to be the most stable is the testing tool you're using, right? You never want to be in a position of asking, did this break because it's broken, or did this break because the testing tool broke? In electrical engineering, the wires you want to shield the most are the ones carrying the telemetry, right?
That's fair. Do you feel like that's coming from a place of, and I don't know specifically what changes you might be referring to there within RSpec itself, but and for everybody listening that's not part of the Ruby community, RSpec is one of the popular testing frameworks that, it's not the one that comes shipped with Ruby necessarily. I think Minitest comes within standard lib, but it's a gem that you can bring in, and kind of like the BDD approach to writing tests. It's very popular. It's very, very popular. Big fan of it over the years myself. I've been trying to wean myself off of it in a weird way to just reduce complexity on some smaller projects, for example. But I still really, really do like it. But it will, even the people that original creator has said, like, I wish people would stop using it. But for what it's worth, do you think there's anything, like there's something about how developers, whether they're trying to be overly clever, reduce the lines of code, and maybe embracing the dry, don't repeat yourself a little too much? And I don't know if that's necessarily the spirit of, that was Dave Thomas, I think.
Certainly that's where I discovered it.
Sure. And like I've had people on the podcast and they talk about like wet tests, and like they're like, no, like when you're writing tests, like if you try to like try to share too many things in your test and the setup process, then you're maintaining a bunch of other complexity that you don't actually need to run some tests. So where do you kind of land on things like that yourself?
First, let me say that the people behind RSpec are building software that I get to use for free, more or less out of the goodness of their heart. And so let me say that thank you.
Yeah, thank you.
The other thing I want to say is I think it's all coming from a good place. And but I also think there is a certain level of people changing their stylistic minds that you see in RSpec. How do I express the idea that this thing should be true is a fundamental thing in RSpec that has shifted over time. I can't remember, do I assert it or do I say it is this or, I'm not sure that the changes have really made us better off, but I am sure that they're coming from a good place, right? They're coming from someone trying to say, how can we make this better? But one of the things, so I've spent a lot of time in the Clojure community, and and maybe this is where this is coming from, one of the values of the Clojure community is people will brag, my library hasn't changed in 3 years. And the unwritten thing is, and people are still using it. And that's like a point of pride. The Clojure team, the core Clojure teams tend to publish this chart where they show you how little of the Clojure source code has changed over time. And the feeling is, we got it right. And we're stopping, at least for some large chunk of it.
And I think that seems like let's try to avoid, they're focusing maybe, I don't know a ton about the Clojure community, but it seems to be, let's keep things stable. So we're coming at it from a different maturity mindset. And I think maybe in the Ruby community, we also, at least maybe because we do a lot of web application development and we're trying to pivot quickly. So we pride ourselves in being malleable and being able to move things. And so, but there's also a cost to when everything's moving and you're trying to move and you're like, I actually just want to have this thing be stable. Why does every upgrade seem a little bit more complicated? Because it's the Ruby gems, the different dependencies, and kind of like maybe speaks to the types of software that we're writing, like what's the end type of product deliverable there. And I think that's what I was mentioning earlier. I was doing some mini tests for examples when I'm trying to work on some projects where I'm like forcing myself to let's just stick to standard lib as much as possible. Because I don't want to touch this for several years if I don't have to. Whereas if I'm doing something, I'm like, I need to probably benefit from what the community is providing here. And so
I will say this, that having worked in both, I think of the Clojure world and the Ruby world as kind of opposite ends of this spectrum you're talking about. I will say, having come back to the Ruby world after being away for a long time, the sort of wildly experimental, we will try anything feeling of the Ruby world is just wonderful too. And I think, again, it sort of goes back to how we opened this conversation. You're maintaining the software for what? For how long? For who? For whom? And so I think you could probably make a cogent argument that Clojure is very maintainable in its own way, and some Ruby application or maybe RSpec or something is maintainable just on a different dimension of maintainability. And as you say, like, what am I using it for?
So let's take that idea and ground it in the reality of existing software systems. So you've talked about how legacy systems can turn engineers into pessimists, something that I read. I'm air quoting. Everyone knows about a system is often just wrong. So why do these assumptions sometimes stick around for too long?
I think in particular with legacy systems, they can be exhausting, right? Maybe you're relatively new to this project. You've got, I don't know, 100,000 lines, 1 million lines of code, something like that, like more than you're likely to understand for a very long time. And you have to fix this very specific bug, right? And that can be exhausting. And so there tends to develop this culture in teams that are maintaining large legacy systems, which is sort of, that's just the way it is. And we don't want to dive into the details of it because it's just a rat's nest. And the only alternative is we need to, rewrite it, or some large chunk of it tends to be the dynamic. So it's a little bit of, you're either a wild pessimist or a wild optimist. The reality is in the middle. I say that it tends to turn people into pessimists because I've seen a whole bunch of cases where that pessimism has caused people to miss obvious things about their system. In a couple of different cases, I got called in to look at the performance of some servers. So this is two different widely spaced incidents. And, this server is performing horribly and we need to rewrite it because it's just a mess and it's never going to, perform well. And dig into it for a while and discover someone's left the debug option on. There was a Rails system that was doing the Rails thing of reloading all of the classes all the time. And someone had accidentally enabled that in production. And, it was this horribly performing server that everyone knew was, just intrinsically it was doing an intrinsically difficult thing, only it was doing it, at 1/4, 1/10 the speed that it could have. And then years later, different programming language, completely different application, exactly the same thing happened. And I'm not brilliant, and these are not stupid people we're talking about. It's just that they were sort of in the world of this system where it was exasperating and they were used to being exasperated. I will say this. If you are in that situation where you're working on a large sort of existing code base that's difficult and convoluted and things like that, and you have a new person come along, you've got a new team member, a new engineer, transfer or something like that, that person is a valuable natural resource, right? It's very easy to find the most junior member of the team and say, get Sally up to speed, right? Oh God, we got a new person, we got to get them up to speed. What you should be doing is listening to every single thing they say, because 90% of it will be, why don't you just do this when you've thought about doing this for 100 times? And 10% of it will be brilliant insights that you never thought of because they're new. They're looking at it with fresh eyes.
We'll be right back with the interview with Russ. Hi, it's me, Robbie Russell. If you're finding Maintainable valuable, please consider sharing it with a peer or leaving a review on Apple Podcasts or Spotify, or wherever you kids are hanging out these days. If there's someone you think I should have on the podcast sometime, send me a note to Robbie with a Y at maintainable.fm. And now let's get back to our interview with Russ Olsen. I think that's very valuable, and I concur with that. It's like why I think it's so important to, when you're onboarding people. It's also, as I say selfishly, as a working in the consulting space, when you bring in an external perspective, it isn't just to add another body to the project. It's you're often bringing in a different set of skills and questions and ideas and pattern recognition that you may drastically benefit for really quickly. You never, so sometimes people are like, I don't know if we don't have the energy or the budget to bring somebody in for this particular thing, but just getting a new perspective in the room that doesn't come with all those baked in, that pessimism about your system, or, oh, we already tried that, or I think we already tried to look into that. And you're like, well, I'm going to try, let me just look at this again from a different perspective, because you could just completely overlook something like a debug thing in your code or something. And that, hopefully that's not the reason you need to bring a consultant in, but those are the benefits of bringing in an external perspective sometimes. And I say that as someone that runs a consultancy, we bring in consultants to help us improve our consultancy. And we had to learn that, like, oh, that actually is really helpful for us too. And if we're not willing to do that ourselves, then why would anyone ever hire us to do that? And getting an outside perspective is helpful. But I'm also thinking about that pessimism part of it a little bit more. And when teams start to kind of drift into that space, because I'll talk to a lot of teams and they're kind of like, well, we've tried that, or management doesn't want to prioritize dealing with these issues right now, or we just kind of have to live with the state, or I got hired into this and this is how it's just always been. So who am I to change this? So where do you think these, maybe a myth kind of approach within that team, where do you think that usually originates?
I think it's the nature of working on a code base that you don't fully understand, that you don't have, we talk a lot about ownership, but if I build it, I own it. If someone else built it, it feels less like I own it. And if it's 10 people built it and it's kind of messy at this point, maybe I don't really feel like I own it. But What you can own is the goals of your team and doing a good job. I think one of the things that you can do if you've got a large, messy code base that you're trying to deal with is to look for the pinch points in the systems. A pinch point is like a place where all of the activity of this kind goes through. So an obvious pinch point is like if I've got a relational database, where does the SQL get generated and go out? And where do the results come back? Typically, you can find that place in any system, even if it's as far down as the database driver. And that is a place where you can like have absolute confidence that you know what's going on at this point in the system. There's a bunch of SQL going out and there's some results coming back. But even really, really messy systems tend to have pinch points, and sometimes people aren't aware of them. All of the activity of this kind goes through this function or this object, or maybe this small set of objects. And that is, if you can find those places and start looking at what's going on there, you can start to get this intuitive feel for how the system works. And that helps get rid of the pessimism because you're like, no, it's not this giant black box. It's 10 gray boxes now. I can sort of see how they go together. A great example of that early in my career was I worked on this mapping system that had a scripting language. There was a interpreter for the scripting language that had all the mapping primitives in it. And then there was a scripting language where the applications were essentially written. And what we really needed was a debugger for that scripting language. And, the thing was kind of this giant mess of C code and how are we going to build a debugger? And someone, not me, realized that the scripting language had a trace feature where you could turn on logging and it would tell you every statement that it was executing. But it did that sort of in real time, which meant that we had a place where we could see every statement every expression that the language was executing. And from there, we kind of built a debugger based on that, So that was a pinch point. We found the place where all of the activity we were interested in was flowing through.
When you think about encountering, let's say, existing older systems and given your tenure in the software industry, I know that teams will sometimes struggle with thinking about how they're going to improve their testing or observability or dealing with really painfully slow builds or deploy cycles. Which of these do you think tends to cause the most long-term damage?
Incredibly long build, and it's the cycle time that will kill you because that's the cost you pay every day, every minute, every hour. Right. So yeah, the waiting is the hardest part. The thing that people tend not to pay attention to in legacy systems, of which the waiting, the cycle times is the primary example, are simply the quality of life things for the developers, right? If you have a team of developers who are shouting about how they hate working on a legacy system, what they're probably shouting about is how long it takes to build and deploy, how hard it is to test, how hard it is to figure out what happened where, right? There's all of these sort of, engineering kind of quality of life things that tend to not get prioritized in a large system that are more important in a large system than almost anywhere else. And so I think you're touching on a great point, which is that's how you can kind of make people happier, is if you can, just generally make the system easier to deal with. There's a great analog, which is early military submarines were miserable to live on, right? Take a bunch of people, put them in a metal tube, put them under the water in the South Pacific, right, where it's hot. You can imagine what that does. And there was a feeling of, well, we don't want to coddle our people and that kind of stuff. But if you want an efficient crew, you put air conditioning in the submarine, right?
That is a good analog, a kind of example to think about. And it's so funny how often we'll come into consulting engagements or I'll come in to talk with teams And the companies will talk about how much they will invest in their employees, in their space, especially pre-pandemic when it was like before everybody was working as remotely as you've been doing it for a long time now. But there was a lot of emphasis around physical space, physical comfort, access to things. But then you would talk about getting budgets for like dealing with your test suite or dealing with just developer ergonomics of making your quality of life as a coder working on the software project. Well, we don't have the budget for that right now. Like the perception is like, oh, but I also do think that part of that problem has been that it feels like this given or like we're asking for permission to do our job better. And that's something I struggle with developers where I feel like they're like, well, I'm air quoting the stakeholders aren't prioritizing this right now. They're telling us to just ship stuff and they're not concerned about testing or as much as we would like them to be. And then I'm always like, well, you're also the ones deciding what done is, right? So like, what does it mean to produce some bit of code and maybe thinking of like just test coverage as being like an extra thing as an example. It's like, I was literally talking to a developer this week and they're like, oh, I'll kind of pad my estimate with like 20% more so I could do those extra things, like work on extra documentation and testing. And I'm like, is that not just part of the process of you're treating it as extra. So when you're having conversations with other people, are you talking about these things as extra things rather than just being the thing? And I think we're not doing ourselves a good service by talking about it that way.
I think we tend not to do ourselves a good service by having an all or nothing kind of attitude. So I've managed software teams and
I'm sorry. I'm so sorry about that.
Well, more than that, I've been an engineer, I've been a manager, I've gone back and been an engineer and done that several times, which gives you a different perspective on it.
I'm sure.
But, if some engineers come to me as a manager and say to me, we want to spend 20% more time and write some tests and do, make life better and it'll be better for everyone in the long run, that is a heck of a lot more likely to get a yes than we need to stop everything for 3 months while we fix the testing suite, right? And it's like, if you can, again, I think engineers tend to think this is this sort of project version of I document my functions, but not the whole system. We tend to think of how can I fix this problem right now? How can I have a good test suite? If I stopped everything and worked on the test suite for 3 months, how can I do this? And what you really need is to sort of say, how do I break this into small bite-sized pieces that my manager, who might be completely sympathetic to what I'm trying to do, can take it to their manager and get it approved? Because, frequently the decision maker is not the actual decision maker.
What's the smallest improvement that you think teams could make that you believe creates real leverage?
Just think about testing. If you have a system that has no tests, which I'm sorry to say is all too common, writing the dumbest, most coarse tests that you possibly can, the finest grain, but don't worry about how fine grained the tests are. A system with 5 very basic tests, which are sort of like I turn it on and it does not catch fire, is better than a system completely without tests. Like if you have a system with 10 subsystems and you have tests that simply say this massive subsystem is doing some basic things coherently, and you do that for all 10, you are enormously better off because something goes wrong. You can run those tests and at least maybe have an idea that 90% of the system is working fine. And my problem, I've just reduced it, or 100% of the system, to 10% of the system. I think just taking a minute, just psychologically taking a minute and finding the thing that annoys you the most and fixing that, like do something for yourself, right? Give yourself a gift, and that's like put air conditioning in the submarine.
Let's zoom out and talk about change at, say, a slightly bigger scale. Now, in some of your writing, you've warned against rewriting parts of a system without understanding why they exist and why they ended up that way. So what's the most common story that teams tell themselves before starting a rewrite?
Oh, how hard can this be? Give you an example. Worked on a system that was essentially a query. system. As a user, I would sit down and I would say, I would like to know this thing. And it would bring up a form and I'd fill in some fields. And it was like basically like a query by example kind of thing. And it would go out to this massive, massive database, do a query and bring it back. Except the system as I found it, the queries that you could do were very, very coarse grained. So I'd say, give me, just let me run this query, and it would bring back 200,000 rows. Okay. And then, so the poor users, what they'd have to do is they're not really interested in 200,000 rows. They're interested in, the biggest value of the runway length. It was kind of a geographic system, right? And so they would have to sort locally 200,000 rows. It would happen in like the local server. And, that had memory implications. It was like, CPU time. It was awful, right? What the heck were these morons thinking? So there was a project to completely rewrite the system and give the users fine-grained control over, the queries so they'd bring back the 10 rows they were actually interested in. And that, we spent a lot of money and a lot of time on that, only to discover that this database that we were querying was actually a composite database. It was actually, kind of a virtual database made up of hundreds of other data sources. And if you did the wrong query, it would bring those other databases to their knees. And that's what those idiots were thinking about, And so what we ended up doing was pulling the data local and finding a better way to sort of do the local queries instead of just having the poor user push sort and go get a cup of coffee.
When teams are underestimating the complexity of a rewrite, when do you think they kind of become a form of maybe avoidance?
Me personally, Russ Olsen, I would much rather work on software where I'm writing new code, where I understand exactly what's going on. I'm starting with a clean sheet of paper. I have my requirements. And I said, that is so much more fun than going in and looking at whatever crazy stuff you did 10 years ago, someone else. And so there's this strong pull, just like a psychological, this is more enjoyable work than this other stuff. And that there's nothing wrong with that. Everybody wants to do enjoyable work. It's just sometimes not the right business decision. So, if you're going to rewrite some crazy bit of some legacy system, you really need to understand the requirements, right? People talk about understanding the requirements of a new system and how hard that is. It's much more difficult to understand the requirements of some existing software where you can't talk to the customer. Maybe all you can do is look at the code and try and talk to the code.
I mean, you don't always have access to, say, all of the behavior of that software necessarily. You can try to wrap your head around that, all the different edge cases and maybe politics that went into how it is, and like that's the allure of a rewrite. But I also find that there will be teams that, because of that, as you mentioned earlier, there's a little bit of that pessimism, that they start to get this in their mind that the only way out of this is to, one day we're going to get to do a rewrite. So I will just deal with whatever the situation we're in, the slow builds, the inadequate test coverage, what have you, all those little pain points, because we're going to one day get away from all this. And so they're like, let's stop trying to improve this situation because we're going to one day have a better solution that we start working towards. Does that ever really end up happening very often?
The way you rewrite, in my experience, the way you get a rewrite of that big, ugly legacy system, the way you actually do it is you do it a piece at a time. And what that means, unfortunately, is the thing you come out with is not quite as beautiful as you might like it, because you're sort of rewriting it a piece at a time, replacing the parts of the horse and you end up with a camel. I don't know. Unless you've got some organizational, of course, it all depends on the scale that we're talking about, 100 lines of code versus 100,000 lines of code or something. But for really significant systems, again, you have to think incrementally, because unless there's some enormous sort of business reason to replace this thing, you can maybe do it a piece at a time. But doing it a piece at a time also involves understanding how the existing one works, and not just you need to kind of write it down, you know.
I think this all points back to people, not just the code as well. And you said software development is fundamentally it's a social process, right? And so we tend to keep trying to simplify it, I think, a little by focusing on our code, our eloquent code, our beautiful code, our maintainable code. But where do you think this simplification caused the most harm?
I think that we have an aesthetic of how we want things to look. And we feel better when things are pretty for whatever definition of pretty there is. And to the extent that that lines up with the actual reason we're building the stupid thing, make the bank work or whatever, keep people from stepping on landmines, right? That's wonderful. But sometimes it departs from what the actual goal of the thing is. And that, I think that's the thing I learned, from my trip from engineer to manager several times is, there's a different mindset with, I think, good engineering managers, which is you care about the people who are working for you. So you really want them to be happy and you want them to have interesting work and fulfilling work, but you've also got to do the thing. That's a balance. And if you can get that balance right, you have happy people doing the thing you need to be done. I also think one of the things I feel strongly about is technical people, especially managers, do not value storytelling enough, right? I think, humans have been telling each other stories probably since we've been human. And best ways to communicate like the actual goals, the thing we're trying to do to engineers who are in the middle of, all of the details of it is to tell them a story. The bank has a problem because we're dropping these transactions. So imagine this person is using their credit card and it doesn't go through and it's Christmas Eve or whatever, it doesn't have to be that extreme. But as opposed to here are the requirements, do it,
We'll be back with our interview with Russ in just a moment. Hey, it's me, Robbie. I want to take a quick moment to talk about something we've been helping more teams with lately: fractional development. Not every company needs a full-time engineering team. Sometimes you just need a few experienced developers to keep things moving, handle maintenance, fix bugs, help with upgrades, or tackle the stuff that's been sitting in the back burner for way too long. That's where my team Planet Argon comes in. We work with companies who want to keep their software running smoothly without the overhead of hiring full-time engineers. Good software deserves a second act, and we're here to help make that possible. You can learn more at planetargon.com. That's planetargon.com. All right, let's get back to our conversation with Russ Olsen. Do you think that it's been your experience that developers are more, we're thinking about like let's say tickets and user stories, or however teams are organizing the requirements and passing them off to developers, or developers are crafting those themselves and working on and dividing and conquering amongst their team? Do you think that we spend enough time telling stories amongst ourselves, or do you have any advice on how anyone listening could maybe level up on their storytelling skill sets outside of it being just sharing their own like personal anecdotes about things? And where's that kind of that line there?
I think the kind of storytelling that I'm talking about starts with people wanting something and ends with people getting something or the world changing for them. And one of the things that makes me, as someone who's like told stories and, in the social human way of talking about stories, the thing that makes me crazy about the like agile story kind of thing is those aren't stories. Those are a set of requirements in some stylized form. A story really is about a person having a need and the need getting satisfied, where the key ingredient in it is the person or people. Stories are all about people. There's no story about a Chevy Impala or something like that. An object doesn't have a story. A person has a story. And so, but if you look at sort of in the agile way, it's like, yes, they talk about the user, but the user is just kind of this, could be an AI, right?
The user wants to drive their Chevy Impala So they need to be able to have a doorknob, and it's like we get very prescriptive, and it's just like, where's the person trying to get to? What are they trying to do? They're trying to get to their date on time, and like they're trying to impress a girl. And it's not, that's the story. It's not, I wanted to start the car up and start driving. Like they're trying to do something that's part of and we're building tools quite often to help people do something that's way bigger than the tool itself. And so that's an interesting perspective.
I will say I only worked on this system very briefly, but it made a big impression on me. No one had to repeat the story of the landmine system. Everyone understood this was about not having people not step on landmines, who had nothing to do with, anything, right? And that's a very compelling story.
Yeah. How do you write test coverage for that sort of scenario?
Carefully.
Slightly tongue-in-cheek there. Yeah. I'm trying to think of like what a user testing looks like in that scenario.
Well, user testing, I think the tests always end with, and then nothing happens.
That's good. Well, Russ, I've kept you long enough, so I want to kind of wrap up with a few things. But first, I want to get your advice for our listeners. So you already kind of mentioned like maybe that dumb test is one example. But let's say there's someone listening right now and they work on a team and they feel like they've advocated for maybe dealing with some thorny, like we're addressing some of the more thorny parts of their software project a few times. And maybe they've heard, not right now, maybe later, we'll come back to this. Or maybe they've tried to get a little bit of buy-in from their team and like it doesn't seem like other people care as much as they do right now. So they've stopped bringing it up for whatever reason. They're just kind of complete. And then I say maybe they're not feeling complacent, but they're just like, I don't know what I can do about it. Do you have any advice on something they could start experimenting with this week that might start moving that in the right direction?
Okay, so I won't pretend that I have perfect advice for every person, right, in every situation. I can say that one of the things that has worked for me in my career is, if you're going to do something this weekend, go off and do something as far away from your day job as you possibly can, right? For me, it was, I didn't have the sexiest day jobs early in my career, but I was really interested in programming languages and how compilers and interpreters worked and that kind of thing. So I got interested in that, and it had absolutely nothing to do with anything until my career started to revolve around it. I think find the things you're interested in as like a side project, something to learn about or whatever. If nothing else, you will have something to look forward to and you won't be frustrated. But these things have a way of like circling back around. So my interest in programming languages and how they're built and everything has come in handy any number of times just in like the boring kind of everyday problems that I face. But your answer might be different. Find the thing that you're passionate about. At least you will learn something, and the learning will be easy because because you're interested in it.
I think that's good advice. By chance, is there a non-software, non-technical book that you find yourself recommending to peers?
At some point very early on in my career, I was sort of at this crossroads where I didn't like what I was doing. And so this is very much in the theme of go off into left field and do something completely different. And I read a couple of books that, I don't know, had an interesting effect on me. And the two books were a novel called Zen and the Art of Motorcycle Maintenance, which is one of those classics. And the other book was written by a guy named Bertrand Russell, and it's a history of Western philosophy. And all right, well, both of these books are in different ways about philosophy, and they're both kind of heavy in their own way, but I don't know, I came out of those books thinking about different things than when I went in. So I'm not sure that would work for everyone, but those are books that I talk about frequently.
Bertrand Russell is one of those people I share a surname with that I'm like, I wish I was related to him, but yeah.
Well, me too, sort of.
Oh yeah, I guess that's true. We both got that.
Yeah.
And for our listeners, I'll include links to both of those in the show notes for everybody as well. And where can listeners best follow your thoughts and thinking and ruminations about software engineering online?
So I am Russ Olsen on Blue Sky, on Mastodon, and on LinkedIn. So any one of those places if you're not sick of hearing the sound of my voice after this podcast, I can fix that.
Well, I'll definitely include links for those as well for our listeners. Russ, this has been a real pleasure. Thank you so much for joining me on Maintainable and talking shop with us.
Hey, it's been a pleasure. Thanks for having me.
You've been listening to Maintainable, a Planet Argon production. Editing by Claudia Armbruster. Post-production by Autumn Morgan and Ellis Fenson. Emotional support from the letter M. For Maintainable, for momentum, for making things better. If this episode resonated with you, share it with someone who needs to hear it. Keep showing up. See you next time. Maintainable.